Dear students, in the last session we have defined what is meant by stagnation enthalpy, and from the stagnation enthalpy we finally ended up with the stagnation temperature. Today we are going to see about the stagnation pressure and stagnation density. In the last session we have taken initially the adiabatic energy transformation equation, which is given by H1 plus half C1 squared is equal to H2 plus half Ct squared. In such a case, we have taken a condition in which the flow is coming from 1 and it is going to be stagnate at condition 2. That is, the flow is going to made to rest at the point 2 by adiabatically decelerating. The term is very important. Okay, the term, which term is very important means the flow is brought to rest. The flow is brought to rest by adiabatically decelerating. So the key word is what? Adiabatically decelerated to zero velocity. So the velocity Ct should be brought to 0 at 0 elevation. At 0 elevation. So the very important keyword is adiabatically decelerated. What is meant by adiabatically decelerated? There is no heat transfer from the system to the surrounding or from the surrounding to the system. Okay, which means now we are trying to make C2 equal to 0. So the starting position can be anywhere, but finally we are going to make the flow to get stagnated by adiabatically decelerating. So in the above equation, if I am going to substitute now, when C2 equal to 0, my H2 will become H0. So what is H0? Stagnation enthalpy. So these things already we have seen in the last class, but still it is important that we will recall and find the difference between stagnation enthalpy, stagnation temperature and stagnation pressure. There is a difference between stagnation temperature and stagnation pressure. So that we are taking much time. So let us go with like this. So H1 plus half C1 squared is equal to H0 plus 0. Why means it is 0? So the entire term become, the right hand side becomes what? H0 equal to, the left hand side is H1 plus half C1 squared. As we discussed in the last class, the left hand sides are variables. H1 and C1 can take any value, but H0 is a constant. That's what I told in the last session also. Instead of starting from 1, I can start from 3 also. But I will end up with what? At 2. 2 means at stagnation state. This is nothing but your stagnation state. So there is no meaning of 1 and C, which means my H0 equal to what? H plus half C squared, which means here the H and C are variables and H0 is a constant. So we got H0 equal to H plus half C squared. But when you want to try to go for stagnation pressure, the key word is not adiabatically decelerated. Instead of that, it is called as isentropically decelerated. Isentropically decelerated. So the earlier keyword is adiabatic. Now the keyword is isentropic for getting stagnation pressure. So if you want to get stagnation pressure, the condition is not adiabatic. On the other hand, it is what? Isentropic. So what is the isentropic? Isentropic is nothing but reversible adiabatic. So we are adding an auxiliary term called as what? Reversible. So it is not only sufficient that the process should be adiabatic, but also it should be reversible. But also it should be what? Reversible. So if you want to attain stagnation pressure from the stagnation states, that we can see in case of getting stagnation enthalpy or stagnation temperature, it is sufficient to go with adiabatically decelerated. On the other hand, if you want to get stagnation pressure, it should be isentropically decelerated, which means it is reversibly adiabatic. So we have an auxiliary term called as reversible. So it is not sufficient that for getting stagnation pressure, the process should be adiabatic, Moreover, it should also be reversible. That is the main condition we should know. So, it should be isentropically decelerated to zero velocity. That at the end of the session, we will come to know why it should be like that. At the end of this session, we will come to know. Before that, let us try to derive the various forms of energy transformation equation from the stagnation enthalpy equation, namely the H naught plus H naught equal to H plus half C squared. So, we have H naught equal to H plus half C squared. We know H is given by Cpt, H naught then will be given us by what? Cp into T naught. If it is going to be capital H, it will be mCpt. If it is going to be capital delta H naught, it will be what? mCp, T naught, etc. So, we know the H naught is given by Cp into T naught and H is given by Cpt, where Cp is the specific capacity at constant pressure and T naught is the stagnation temperature, T is known as the static temperature and C is the velocity of the fluid or the velocity of the object or the velocity of the flight, whatever you may call you. So, now we divide this entire equation. Let us call this equation as 1, let us call this equation as 2, let us divide the equation 2 by Cp, we will end up with T naught equal to T plus half C squared by Cp. So, I have divided the entire equation number 2 by Cp. Now, let us call this equation number 3. We will further divide this equation by T throughout. So, it will become T naught by T is equal to 1 plus 1 by 2 into C squared by Cpt. Let us move on to the next slide. So, we got T naught by T is equal to 1 plus 1 by 2 into C squared by Cpt. So, it become 1 by 2. So, what is Cp in terms of gamma and R? In the previous section we have derived it. So, I will directly take the value, it is nothing but gamma R by gamma minus 1. So, students, please know that you should know that Cp is given as what? Gamma R by gamma minus 1. So, I am substituting for Cp, it becomes gamma R by gamma minus 1 into T. So, I can take this value 1 by 2 gamma minus 1 by into C squared by gamma RT. In the last session also I told you this A is nothing but the square root of gamma RT. Hence, A squared will be equal to what? Gamma RT. So, you may be wondering what is A? A is nothing but the velocity of sound. Velocity of sound. What is C then? This is nothing but A. What is C then? Velocity of fluid or flight or object. Okay. So, this is nothing but the velocity of fluid. Now, we can see here 1 by 2 gamma minus 1 into C squared by A squared. We also know that the Mach number is given by C by A. It is a ratio, there is no unit, velocity of the fluid by velocity of the sound. Generally, we are using this Mach number for the flight and hence it will travel in air. So, generally the A is called the velocity of sound in air and C is the relative velocity of the flight with respect to the atmosphere. Okay, fine. So, we got T naught by T is equal to 1 plus gamma minus 1 by 2 into this is nothing but what? M squared. This is nothing but what? M squared. So, here what are the variables? T and M are the variables. T naught is a constant, which is nothing but what? Stagnation temperature. So, if I want to put like this, T naught by T1, it will be equal to 1 plus gamma minus 1 by 2 into M1 squared. If I want to put T equal to T2, then M will become what? Yeah, M2. So, we can see here T naught by T2 will be equal to 1 plus gamma minus 1 by 2 into M2 squared. Okay, that is fine. Let us move on to the next slide. So, we have once again this stagnation enthalpy equation H plus half C squared equal to H naught. Now I am going to derive the various forms of this energy transformation equation. What is H? You know that Cpt plus half C squared equal to what? H naught. What is Cp in terms of gamma and R? Now only we told it is nothing but gamma R by gamma minus 1. So it is gamma R by gamma minus 1 into T plus half C squared equal to H naught. What is now this gamma RT? Yeah, you are right. It is nothing but A squared. Just now we saw A squared is nothing but what? Gamma RT. Or A equal to what? Square root of gamma RT. So we can see the numerator is nothing but what? A squared. So A squared by gamma minus 1 plus half C squared equal to H naught. So what I want you to visualize is that whenever you are seeing an equation like H naught equal to H plus half C squared, which is nothing but the stagnation enthalpy, your mind should also reflect that A squared by gamma minus 1 plus half C squared equal to H naught. Both are one and the same. Both are one and the same. There we express in terms of what? Static enthalpy. Here we are expressing in terms of what? The velocity of sound in air. The velocity of sound in air. So A squared by gamma minus 1 plus half C squared equal to H naught. So now we can see once again the terms which are on the left hand side are variables. So what are variables? A and C are variables. Why? A is nothing but what? Square root of gamma RT. Gamma is a constant, R is a constant, whereas the T, static temperature, can take any value. So A is a variable. C is also a variable, whereas the right hand side H naught is what? A constant. Is constant. Now I want you to think and tell me when C will become C max. I will repeat the question. You please see the equation number 4. A squared by gamma minus 1 plus half C squared equal to H naught. Here I want C to be what? C max. So when C will become C max? When this term becomes 0. Or I will tell you like this. This x plus y contributes to 100. Let us assume that x is nothing but what? A squared by gamma minus 1. Y is nothing but what? Half C squared is equal to 100. Now when y will become 100 or y will be the maximum value when x equal to 0. When this term becomes 0, y should become what? Y max. Y should become what? Y max. So I will recall once again. If I want C to become C max, then the first term should become 0. Now the question is, when the first term will become 0? So we know that A equal to what? This term A should become what? 0. When this first term A will become 0, my students will tell, when gamma is 0, A will become 0. Because that is mathematics. But for any fluid, gamma cannot be 0. For any fluid, R cannot be 0. So the only possibility is that T may be 0. So there is a $1 million question once again. Whether T can be 0? No. Any material in the world will have temperature above absolute Kelvin. I am not telling 0 degrees Celsius. I am telling 0 Kelvin. I am telling what? 0 Kelvin. It is not practically possible. But if it is possible, then my A will become 0. Then my A will become 0. So when T equal to 0, my A will become 0. In such a case, C will become what? C max. C will become what? C max. Okay. So I can write half C squared max equal to H naught. Now my dear students, you please comment or tell me which is constant in this equation or which is variable in this equation. Half C squared max equal to H naught. What is the answer? Which is constant or which is variable? Both are constants because H naught is also constant. Now the left hand side is also only one variable is there, which should also be constant. Okay, got the logic? So half C squared max is also a constant and the value is equal to H naught. And the value equal to what? H naught. This is one of the condition we arrived by making the term A to be 0, by making the T to be 0. Now let us think alternatively. What is meant by alternatively? I will go ahead like this. A squared by gamma minus 1 plus half C squared equal to H naught. Here what I made? I made the first term to be 0. Now what will be your mind? Why not the second term to be 0? Why not we make the second term to be 0, which means let me make the float to be 0, which means your flight is not flying, your flight is standing at a position, is static, there is no velocity, c is not there. Okay, then what will happen? Then this a will become a naught. What is a naught? A naught is nothing but what? Square root of, can anyone tell what the formula for a naught? Yeah, you are right. It is nothing but not gamma or t, it is gamma or, yeah, t naught. It is gamma or t naught. It is not t. Only when a means is gamma t. A naught means gamma t naught. You may be wondering why person put a naught or not a, because the right hand side is h naught. So the corresponding temperature will be what? T naught and not T. And hence I have to put as here was only what? T naught. When I am putting T naught, then the left hand side will become A naught. Then that is the maximum velocity of sound. That is nothing but the maximum velocity of sound. So I can get A naught squared by gamma minus 1 equal to H naught. Let us call this equation as equation number 6. In this equation 6 also, there is no variable. All are constant. A naught is also a constant because gamma T naught, root of gamma T naught. Gamma is constant, R is constant, T naught is also constant. The right hand side is also constant. The right hand side is also a constant. So now what we are trying to do is that we have an equation called as stagnation enthalpy. H naught equal to H plus half C squared. We are trying to make this equation to be visualized from various approaches or various forms. What are those? A squared by gamma minus 1 plus half C squared equal to what? H naught. Now out of this equation, I want to make the first term to be 0. So the second term become what? Half C squared max equal to H naught. In the same equation, I want to make the second term to be 0. Then A become A naught. So it become A naught squared by gamma minus 1 equal to what? H naught. Now all are equal. What all are equal? Equation number 4 is also same. Equation number 5 is also same. Equation number 6 is also same. How? Because A squared by gamma minus 1 plus half C squared is equal to, what is this? H naught. What is for H naught? For H naught I can substitute from equation number 5, half C squared max. For H naught I can substitute from equation number 6, which is nothing but what? A naught squared by gamma minus 1, which is equal to H naught. Which is equal to what? H naught. So we are writing the same equation only. H naught equal to what? H plus half C squared. In other form like A squared by gamma minus 1 plus half C squared equal to half C squared max equal to A naught squared by gamma minus 1, which is equal to H naught. Which is equal to H naught. I hope you can enjoy the various forms of this energy equation. Let us move on to the next slide. So we have this equation A squared by gamma minus 1 plus half C squared is equal to half C squared max equal to A naught squared by gamma minus 1 equal to H naught, which is also equal to a, all are equal to a constant because H naught is a constant. Now I will take this term and this term, which means what? Half C squared max equal to H naught. Because any two terms I can take and I can combine them because they are equal. Because they are equal. So from this, what is C squared max? C squared max equal to 2 into H naught. From this, what is C max? I have to take the square root on either side. So square root of 2 into H naught. What is H naught? We already know that it is nothing but Cp into T naught. Because H naught is there, T should be equal to T naught. Yeah. What is Cp? Already we know. What is Cp? That gamma R by gamma minus 1 into T naught. What is the left hand side is C max. Now, what is the square root of gamma T naught? Yeah, it is nothing but A naught. What is here? You can see in the numerator there is a term called square root of gamma T naught, which is nothing but I can write like this: C max equal to A naught. Why A naught? Because T naught is there. Into square root of what? 2 by gamma minus 1. These three terms I made as what? A naught with the square root. So from this I can take what is C max by A naught. So let us call this value as what? 2 by gamma minus 1. The right hand side is nothing but a constant. C max is also a constant. A naught is also a constant. So constant by constant should be equal to a constant. So if you are going to divide, you will get some numbers for air. For air, gamma equal to 1.4. My students will consider gamma equal to 1.4 for all the fluids. It's not so. Only for air, gamma equal to 1.4. For nitrogen, it will have different gamma value. For diatomic molecules, it will have a different value. So gamma for air only 1.4. So if you want to derive for air, you can substitute the value as gamma is what? 1.4, because most of the time the flight is going to travel in the atmospheric air. Yeah, fine. So let us call this equation, let us give some equation number. Let me call this equation as equation number 7. Let us move on to the next slide. So we got C max by A naught equal to square root of 2 by gamma S1. Now H plus half C squared equal to H naught. H plus half C squared equal to H naught. Now I want to define what is Mach number. Already we know that Mach number is given by what? M equal to C by A. This is, let it be equation number 1. The same equation only I have taken. Mach number equal to what? C by A. When C is equal to A, then C is called as C star. We are giving a special notation. When C equal to A, when both C and A are same, we are calling C as what? C star. We are calling A as what? A star, which means C star will be equal to what? A star. I will repeat once again. We know the Mach number is given by C by A. Now I am taking a particular condition in which C equal to A. When C equal to A, we are calling C as C star. We are giving a special name. C as what? C star. And A as A star. So when I am going to put C as C star equal to A star, then my Mach, this particular Mach number is called as Mach critical, will be equal to what? C star by A star. But we know that C star and A star are one and same, which means A star by A star or C star by C star, which is equal to 1. Otherwise I can tell this M critical is something but sonic Mach number. Sonic means what? Now the velocity of the C equal to A, which means the velocity of the flight will be same as that of the velocity of sound. I will repeat once again. C equal to A, which means the C is nothing but what? The velocity of the flight. The velocity of the flight will be the same as the velocity of the sound in air. So it is going to travel at the speed of the sound. So that particular sound is called what? Sonic. Sonic means the speed of the sound. So we are calling when M equal to 1, it is called as sonic velocity or sonic Mach number. Is called as sonic Mach number, and the corresponding Mach number is called as M critical. It is called as what? M critical. Now we know that C star equal to what? A star. Can any of you tell me what is the formula for A star? You are right. You please come on. Yeah, it is nothing but gamma R into, it is T or T naught or T star. Yeah, you are right. It is T star. So A star is given by square root of gamma T star. If it is A means what? Square root of gamma T. A naught means what? Square root of gamma T naught. So similarly we have A star means is nothing but what? Gamma T star. Now with this idea of sonic Mach number or critical Mach number, we will try to go to the equation number 1. We will try to explore more with the equation number 1. What is equation number 1? Where is 1? 1 means I can, for example, if I am going to take a nozzle, I can travel from this one, 1. 2 can be anywhere. 2 means I am telling about the stagnation. It can be here or here or here, somewhere. Okay, let us say I have here it is. I will brought the flow to rest at the point here. Okay, it becomes H naught. It becomes what? H naught. So the flow is abruptly brought to rest by adiabatically decelerating to zero velocity if you want to get the stagnation enthalpy. Now, why can't the flow starts instead of 1, I can write like this: H star plus half C star squared equal to H naught. Can I write equation number 1 as in equation number 2? Students, I will repeat the question. Can I write the equation number 1 as that of 2 what I written here, which is nothing but what? H star plus half C star equal to H naught. You are right. You can write. Why? Because I told you yesterday itself, or today also we discussed now. From 1 also the flow is brought to rest. From here also I can brought to rest. So star is some location somewhere here, which is also brought to what? Rest. So the initial condition can be either 1 or 2 or 3 or even star, or even what? Star. So what is star? When the Mach number is 1. When the Mach number is 1 is called as what? Is a particular condition where the Mach number is what? 1. So the Mach number 1 is brought to what? 0. So my initial condition is got, Mach number is 1. What about this condition? My Mach number is 0. Why the Mach number is 0 at a stagnation condition? Because M equal to what? C by A. When C is brought to 0, Mach number also is brought to 0. Got the logic? So I am starting from Mach number equal to 1 and I am adiabatically going to decelerate such that my Mach number becomes 0. My Mach number what? Becomes 0 because C2 is 0. Because what? C2 is 0. So the equation 2 is also one of the condition of the equation number 1. Equation 2 is also one of the condition of equation number 1 where the inlet Mach number is 1. Where the inlet Mach number is what? 1. Good. So H star plus half C star is equal to H naught. Now what is H star? Cp T star plus half C star squared equal to Cp into T naught. Cp into what? T naught. Just substitute the values of the H star and H naught. Now from this I want to know what is half C star squared. It will be equal to Cp into T naught minus T star. How I got this equation? I have taken this term over here and I have taken the Cp as a common term. So it becomes Cp into T naught minus T star. So from this I want what is C star squared. So C star squared will be equal to 2Cp into T naught minus T star. We will move on to the next page with this equation. Okay. So the equation I will write once again. C star squared equal to 2 into Cp into T naught minus T star. So what is C star now? Take square root on both sides. So it's nothing but what? 2 into Cp into T naught minus T star. As well as what is Cp? Dear students, what is the formula for Cp in terms of gamma and R? Yeah, you are right. Gamma R by gamma minus 1 into T naught minus T star. The left hand side still remains C star. So out of these two terms, T naught and T star, I am going to take T naught as the common term. You can see if now gamma R by gamma minus 1 into T naught. When I take in T naught as common term, it becomes 1. This term will become what? T star by T naught. I hope you can understand now. Otherwise, you take this T naught inside, it will become T naught. If I am going to take this T naught to the second term, it will become what? T star. So I hope you can, simple mathematics you can understand. So it's nothing but what? C star. Now students, can you tell me what is square root of gamma R into T naught? I will repeat. In this equation we can see the square root of what? Gamma R T naught. Yeah, you are right. It's nothing but A naught. So C star equal to A naught into square root of 2 by gamma minus 1 into 1 minus T star by T naught. Actually, this naught should be written in the subscript. It should not be written in the superscript. But T star should be written in the superscript. So please students listen or recall. Whenever I am writing, the star should be in the superscript. Whenever I am writing T naught, it should be in the subscript. So it's a general notation. If you make mistake also, don't follow it. You just follow this convention. Okay, good. Now, C star by A naught is equal to 2 by gamma minus 1 into 1 minus T star by T naught. Also, we derived the condition for the stagnation temperature, which is nothing but what? T naught by T equal to what? 1 plus gamma minus 1 by 2 into m squared. We also know this equation. Which equation? This equation, we know that T naught by T equal to 1 plus gamma minus 1 by 2 into m squared. Now my question is, when t equal to t star, when t equal to what? T star, what is the value of m? I will repeat the question. When t equal to t star, what will be the value of m? You are right. Yeah, m will become 1. Why? Because in the previous slide only we told that m equal to c by a. C and a are same means c will take c star, a will become a star. So m critical will be equal to 1 or a star will be equal to gamma t star, which means when the Mach number is sonic, my t will become t star. The temperature corresponding to the Mach number of 1 is called as t star. So when t equal to t star, which means my Mach number is equal to 1. My Mach number is equal to 1. That is the idea. Yeah, I hope you got it. Now T naught by T star is equal to what? 1 plus gamma minus 1 by 2 into 1 squared. Why I put 1 squared? Because Mach number is 1. Which means T naught by T star is equal to 1 plus gamma minus 1 by 2. Taking the LCM, it becomes 2 plus gamma minus 1 by 2, which will become gamma plus 1 by 2. So I got the value of T naught by T star as what? Gamma plus 1 by 2. Now I wanted, so what will be T star by T naught? So just the reciprocal. So it will become what? 2 by gamma plus 1. So substitute the value of T star by T naught over to this equation. So substitute the value of T star by T naught as 2 by gamma plus 1 into this equation. Okay, so let us see. So it become what? 2 by gamma minus 1 into 1 minus 2 by gamma plus 1. Now once again simple mathematics only. I am going to work on mathematics only. So we can see here 2 by gamma minus 1 into gamma minus 1 by gamma plus 1, taking the LCM. So what will happen? This gamma minus 1 and gamma minus 1 will get cancelled. So finally what I will get it? I will write it here. I will write here C star by A naught is equal to square root of 2 by gamma plus 1. I will repeat once again. C star by A naught equal to what? Square root of 2 by gamma plus 1. Also, I can write this as A star by A naught. You will agree with me. Why? Because we know that C star equal to what? A star. Both will be same. Okay. So C star, instead of C star, I put as what? A star by A naught equal to 2 by gamma plus 1. Already we had an equation by C max by A naught. We derived in this session in the previous slide C max by A naught. I can show those. Yeah, we can see here equation number 7 I have given. So C max is nothing but what? Square root of 2 by gamma minus 1. So that's going to be equation number 7. I will take that value also. So it's nothing but 2 by gamma minus 1 is given by equation number 7. So I got the value of C max by A naught. I also got the value of A star by A naught. That is also constant, this is also constant. Finally, what I am going to do? What we are doing, sir? We are unable to understand. You are doing some mathematical work and you are explaining some concepts. That's fine. I'll come to that point. I can get your point. So we can see, I will go to the next page and I will make use of these two equations. It will become C max by A naught into A naught by A star. I want to multiply these two terms. What is C max by A naught? Square root of 2 by gamma minus 1. What is A naught by A star? The reciprocal of this term. Because A star by A naught is square root of 2 by gamma plus 1. So A naught by A star will be equal to the reciprocal, which means these two get cancelled. Students, please listen here. When I am trying to multiply C max by A naught into A naught by A star, this A naught will get cancelled. So finally I will end up with what? C max by A star will be equal to what? Square root of gamma plus 1 by gamma minus 1. From this, what is C max? From this, the value of C max is nothing but what? A star into square root of what? Gamma plus 1 by gamma minus 1. So finally, what we try to arrive is that we got C max in terms of A star. What about gamma? Gamma is a constant. So, we are trying to rate the maximum velocity of flight to the critical velocity of sound in air. So, we are trying to give a relationship between what? C max and A star. Now, what we can do is that H plus half C squared equal to H naught has taken the various forms, and I will write all those forms, which is nothing but A squared by gamma minus 1 plus half C squared is equal to half C squared max, which is equal to H naught, which is equal to A naught squared by gamma minus 1, which is also equal to a constant. That's what we have seen so far, isn't it? So, the above equation H plus half C squared equal to H naught can be written or can be visualized as what I have written the below equation. Now, we have derived C max as what? A star into square root of gamma plus 1 by gamma minus 1, which means C squared max will be equal to what? A star squared into gamma plus 1 by gamma minus 1. So, substitute the value of C squared max over here. Now, what is the final form? A squared by gamma minus 1 plus half C squared equal to half C squared max, let it be there, equal to H naught equal to A naught squared by gamma minus 1. Still, I can write half. Inside the C squared max, I will write this value. What is that value? A star squared of gamma plus 1 by gamma minus 1, which is also equal to what? Constant. Now, in order to add this particular term only, we struggled a lot of getting the value of C max in terms of what? A star. So, we can solve any equation based on this one. So, if we know the critical Mach number or the sonic temperature, that is T star, you can find A star. A star is nothing but what? Square root of gamma T star. Once you know that, we can find this entire value, which will be equal to H naught. Which will be equal to what? H naught. When you know H naught, which will be equal to what? H plus half C squared. Okay. So, from that we can try to explore the other possibilities. So, these two equations the student should be aware of for solving any numerals. Numerals is very easy. If you understand the concepts, just substitute the formula, you get the solutions. Okay. So, this is the various forms we have expressed in terms of velocity of sound and velocity of sound and velocity of the fluid. Here the maximum velocity of the flight or the fluid. Here in terms of the maximum velocity of the sound in air. This in terms of what? Critical velocity of sound. Got the logic what I am telling? So, we can see the same H naught can be expressed either in A and C or A star or C max or A naught. That's what we have derived so far. So, don't get worried. It's very easy only. If you go through one or twice, you will get to understand the concept very clearly. So, this is related to H naught. But at the beginning of this today's session, I told there is a difference between H naught, T naught. H naught and T naught are one and the same. H naught and T naught are one and the same in the sense they can be obtained by adiabatically decelerated to zero velocity, whereas P naught is not the same. It is what? Isentropically decelerated. Here is what? Isentropically decelerated. But in order to get H naught and T naught, is enough to be what? Adiabatically decelerated. So, in such a case, I can tell I can put this H naught and T naught in one particular group and P naught separately. When I come to P naught, it is called as isentropically. You also know the meaning of isentropic is nothing but what? Reversible adiabatic. So, it is not even enough to be adiabatic. It should be adiabatic as well as it should be reversible. Then only I can get P naught. Whereas if I want to get T naught, it is enough to make adiabatic. Whereas if I want to get P naught, it is not only adiabatic but also should be reversible. If this concept reaches to your mind, then solving problem is very, very easy. Our numerals is very easy. Let us move on to the next slide and we will try to get the value of P naught. For this, we should know the isentropic relation. We should know what is meant by isentropic relation. So, let us say a process happening from 1 to 2, a process happening from 1 to 2. Let us draw it on a PV diagram. Sometime I will put capital V on the x-axis, sometime I will put small v on the x-axis. When I put capital V, which means it is any kilogram of the fluid, working fluid, which is nothing but what? For any kilogram of the fluid. When I put small v, it understood what? For 1 kg of the working fluid. Got the logic? Which means what? V is volume, small v is specific volume. The unit of V is meter cube, the unit of small v is meter cube per kilogram. Which means if I draw a graph between P and V, small v, then your mind should tell that the graph is drawn for 1 kg of the working fluid. If I am putting P versus capital V, then your mind should tell for any kilogram of the working fluid. It can be 0.2 kilogram, it can be 0.5 kilogram, it can be 1.5 kilogram, it can be 2 kilogram also, but not 1. When it becomes 1, it becomes specific volume. The volume becomes what? Specific volume. So, students, don't get confused with either capital V or small v. I hope you got it. Now, if this process 1 to 2 is adiabatic, is given by PV power gamma equal to constant. What is the meaning of this equation? PV power gamma equal to constant. If I substitute any value between 1 and 2, definitely this value will be equal to constant. It will be always a constant. So, for example, if I have taken this value, so P1, I know what is this P1, I know what is this small v1. So, I multiply P1 and V1 whole to the power of gamma, I will get some C1. Then you take the point 2, this is nothing but what? My P2, this is nothing but what? My V2. You know the gamma, you get C2. Now, the beauty is that C1 will be equal to C2. That is the meaning of this equation. This graph follow this equation PV power gamma equal to constant means at anywhere in this graph, including the point 1 and 2, this equation will be obeyed. This equation will be obeyed. So, this equation is the equation for adiabatic process. Adiabatic process. Okay, fine. Which means PV power gamma equal to P1 V1 power gamma equal to P2 V2 power gamma, which is also equal to constant. It is also equal to a constant. Now, also let us assume the working fluid is ideal. It's not ideal, it's ideal, IDAL. The corresponding ideal gas equation is nothing but PV equal to MRT in terms of mass basis. PV equal to MRT is called as what? Ideal gas equation in terms of mass basis, where P is the pressure, V is the volume, M is the mass, R is called as the characteristic gas constant. Characteristics gas constant, and T is the temperature. And T is the temperature. When you are writing for a universal gas constant, that is PV equal to N R bar T, where N is the number of moles, R bar is the universal gas constant, and T is the temperature. But now let us restrict ourselves to ideal gas equation in terms of mass basis. PV equal to what? MRT. So, P equal to V by M equal to RT. What is V by M? P into small v equal to RT. The same fluid is going to move from 1 to 2, which means I can apply the condition 1 and 2 also for the below equation also, for this working fluid also, which means P1 V1 equal to RT1. Similarly, P2 V2 equal to what? RT2. Now you may ask me a question, sir, why not R1 and R2? You have put a P1 V1 T1, P2 V2 T2, but not R1 and R2. Why I have not put R1 or R2? Any idea? Yes, you are right. Yes, the reason behind is that the same working fluid, the same ideal fluid. So there is no change in the working fluid. So R1 will be equal to R2 equal to R only. So there is no difference between R1 and R2 and R. So I put only R. So I put only R. I hope you got it. So from this, what is V1? V1 equal to R T1 by P1. Similarly, V2 equal to what? R T2 by P2. So I got the value of V2. I got the value of V1 and V2, and I am going to substitute in this equation. Let us call, I will take this part alone and I will call this as equation number 1. So I am going to substitute the value of V1 and V2 from 2 and 3 in equation number 1. Let us move on to the next slide. So here what is the equation? P1 V1 power gamma equal to what? P2 V2 power gamma, as well as V1 equal to R T1 by P1, V2 equal to what? R T2 by P2. Substitute this value in the above equation. So P1 into R T1 by P1 whole power gamma equal to P2 into R T2 by P2 whole power gamma. Now, what is the power of this P1? Yeah, it is 1. The power of P1 is what? 1. So P1 power 1, R power gamma, T1 power gamma, P1 power gamma equal to P2, the power is 1, R power gamma, T2 power gamma whole divided by P2 power gamma. In this equation, which we can strike off? Yes, we can strike off R power gamma and R power gamma. Now, this P1 is there in the numerator as well as the denominator. When this P1 power gamma is taken to the numerator, it becomes minus gamma. So, it becomes P1 whole power 1 minus gamma. I will repeat once again. Here there is P1 whole power 1. In the denominator is P1 whole power gamma. When I am going to take this P1 power gamma to the numerator, the plus gamma will become what? Minus gamma. So, it becomes what? P1 into 1 minus gamma into T1 power gamma equal to, similarly on the right hand side, P2 power 1 minus gamma into T power gamma, T2 power gamma. From this, I will separate the T2 by T1 whole power gamma as P1 by P2 whole power 1 minus gamma. I hope you got it. I have separated the P1 P2 terms as well as this T2 by T1 terms. So from this, T2 by T1 is equal to P1 by P2 whole power 1 minus gamma. Let it, I have written once again the same, just I write instead of x equal to y, I put a y equal to x. Okay, fine. T2 by T1 is equal to P1 by P2 whole power 1 minus gamma by gamma. So this is the expression, I got it. Now if I want to change the terms T2 by T1 as P2 by P1, it become what? I have taken the reciprocal. So the power should become minus 1, which means instead of 1 minus gamma, it will become gamma minus 1 by gamma. So please students, this relationship is called as the isentropic relation or adiabatic relation. If the process is reversible, it is called as isentropic. If the process is irreversible, it is called as adiabatic. So T2 by T1 equal to what? P2 by P1 whole power gamma minus 1 by gamma, or P2 by P1 is nothing but equal to what? T2 by T1 whole power what? I will write as gamma by gamma minus 1. So I am multiplying both the sides by what? Gamma by gamma minus 1. I will end up with this equation. So P2 by P1 equal to what? T2 by T1 whole power gamma by gamma minus 1. Similarly, you can also derive that rho 2 by rho 1 as what? T2 by T1 whole power 1 by gamma minus 1. This I am giving as an exercise. Students, you can try at your home. It is very easy. If you are not able to derive, you can do like this. Rho 2 equal to what? P2 into, or I will tell you, P V equal to MRT, P equal to rho RT. So rho equal to P by RT. So you first find rho 2. Rho 2 is nothing but what? P2 by RT2. Rho 1 is nothing but what? P1 by RT1. Now you substitute the value of P2, P1, T2 by T1 and substitute here, you will get the value of rho 2 by rho 1. That value will be equal to what? Rho 2 by rho 1 equal to T2 by T1 whole power 1 by gamma minus 1. So these three relationships, let us call this equation as 4, 5, 6. These equations 4, 5 and 6 are derived based on the isentropic relationships. P2 by P1 equal to T2 by T1 whole power gamma by gamma S1. So, what is the use of this one? Where we started, we want to end up with a stagnation pressure, but you have told only P2 by P1, but we want P naught, I can get your point. Yeah, let us move on to the last slide. So, already we know that T naught by T is gone by 1 plus gamma minus 1 by 2 into m squared. Now, we got P2 by P1 is what? T2 by T1 whole power gamma by gamma minus 1. Yeah, gamma by gamma minus 1. Now, when T2 becomes T naught, what about P2? P2 becomes P naught. When the condition 2 is brought to stagnation, P2 also will become what? P naught, which means P naught by P1 equal to T naught by T1 whole power what? Gamma by gamma minus 1. Instead of P1 and T1, it can start from any location. It can be variable, which means P naught by P equal to T naught by T whole power gamma by gamma minus 1. Now, we substitute the value of P naught by P equal to what? 1 plus gamma minus 1 by 2 into m squared whole power gamma by gamma minus 1. So, this value of P naught by P is nothing but what we want, where P naught is nothing but your stagnation pressure, P is the static pressure, which we got in terms of gamma and m. Gamma is a constant generally, m is the Mach number. So, if the Mach number varies, then my P1 also varies, I will get the stagnation pressure P naught. But for deriving this P naught, it is not needed only to be adiabatic, but also to be reversible adiabatic. Okay. As in the similar fashion, we can tell rho naught by rho equal to T naught by T whole power 1 by gamma minus 1, which means rho naught by rho equal to 1 plus gamma minus 1 by 2 into m square whole power 1 by gamma minus 1. Now, I told you at the beginning of the session why for arriving at stagnation pressure, you should be isentropically decelerated rather than adiabatically decelerated. I will come to that point now. I will try to draw a TS diagram. Students, can anyone tell what is the area under this graph 1 to 2 is called as? This is nothing but my area. What this area under this graph is called as? Yeah, you are right. The heat transferred from 1 to 2. When the process is happening from 1 to 2, how much amount of heat is transferred either from the system to the surrounding or from the surrounding to the system. It can be either endothermic or exothermic, whether heat is added or heat is removed. So, the area under the TS diagram indicates the heat transfer. That is fine. This idea I hope you know already. Now, let me try to draw a diagram. The same TS diagram. Now, what is for P naught? It should be what? Isentropic. So, 1 to 2 is what? I will draw a vertical line. You please assume this is a vertical line. This 1 to 2 is isentropic. Why is isentropic? The entropy remains same. Entropy remains same means what? S1 equal to S2. So, from here the pressure, I will reach the pressure as P naught. Let us assume the 2 state is a stagnation state. So, I will end up with what? Stagnation pressure P naught when I am decelerating isentropically, because the line 1 to 2 is vertical. When the line is vertical, there is no change in my delta S. There is no change in S. S1 equal to S2 or delta S equal to 0, which means isentropic. I can get P naught only if I travel vertically from 1 to 2 along the y-axis, in the positive y-axis. On the other hand, I will try to move from 1 to 2 dash. This process 1 to 2 dash is called as adiabatic. This process 1 to 2 is called as what? Isentropic. I can get P naught only when I move from 1 to 2 isentropically. And I can't get a P naught if I am going to travel adiabatically along the path 1 to 2 dash. Whereas I can get T naught because T2 will be equal to T2 dash, which will be equal to T naught. This line is horizontal line. Okay. So, we can see that T2 equal to T2 dash equal to what? T T naught. For stagnation, for getting the stagnation temperature, the process can be either adiabatic or isentropic. It's immaterial. At least adiabatic is sufficient. But for getting isentropic, for getting a stagnation pressure, you should be isentropic, which means 1 to 2 should be what? Vertical. Otherwise, what will happen? I will end up with the P naught dash. We can see that P naught dash is less than P naught, which means the stagnation pressure when I am traveling adiabatically will be less than the stagnation pressure if I am going to travel isentropically. So, in most of the books, they may not given this term elaborately, but students, you have to understand that whenever you are going to travel from 1 to 2 isentropically only, you will end up with the stagnation pressure. But if you want to get stagnation temperature, you can travel either 1 to 2 isentropically or adiabatically. This is not a problem. But if you want to get stagnation pressure, you want to travel isentropic. Now, what does the area under 1 to 2 dash indicates? What about the area under 1 to 2? I will draw this graph once again. Please listen here. What about the area under the graph 1 to 2? 0, which means there is no heat transfer. In an isentropic process, there is no heat transfer because it is a reversible adiabatic also. There is no heat transfer. Fine. But when I am going to take 1 to 2 dash, what about the area under this curve? As I already told, the area under NATS diagram is nothing but the heat transfer. So, it is Q1 to 2 dash. Q1 to 2 equal to what? 0, because there is no area under 1 to 2. It is a vertical line. Whereas there is a area under 1 to 2 dash. So, it is Q1 to 2 dash. So, my students will always ask me a question. Sir, you told it's already adiabatic. The process 1 to 2 dash is what? Adiabatic. Adiabatic means what? No heat transfer, which means there should not be any heat transfer from 1 to 2 dash. But here you are showing some area which doesn't reflect is to be adiabatic. Can anyone tell what the answer? There should not be definitely an area under this 1 to 2 dash because adiabatic means there should be no heat transfer. But still there is some area under the graph 1 to 2 dash even though it's adiabatic. Then students, you please help me how I can prove that 1 to 2 dash graph is not wrong. Even though it's adiabatic, but still there is a heat transfer. Yes, you are right. The reason is that it is not reversible, it is irreversible. Because of irreversibility, there are some losses. That losses which will be equal to the heat transfer is shown in the graph as what? The area under the graph 1 to 2 dash. So, the area under the graph 1 to 2 dash is not due to adiabatic nature, it is because of the irreversibilities. If we are able to understand this much, then gas dynamics or thermodynamics is nothing. So, we can come to a conclusion that finally I will conclude now. For getting the stagnation enthalpy or stagnation temperature, it's enough the process to be adiabatic. But if you want to attain stagnation pressure, it is not alone to be adiabatic, but also should be reversible, which means reversible adiabatic, which is nothing but isentropic. So, today we have discussed a lot. Please try to enjoy it and try to utilize this concept in future. All the best. Thank you.